Let us continue with the electrodynamics. Let's focus our energy on the power of the generator. So either DC or AC generator. Now, if we can be given this type of a graph whereby we are given two types, there's one with a small amplitude and another one with a bigger amplitude. Now we are asked to say which one, if the two graphs represent voltage and current graph, which one will be the voltage time graph, and then mainly why. So as a grade 12 learner in physical sciences, you must know that from the formula of Ohm's law, which says R equals to V over I, if you solve the value of I, you find that I equals to V over R, meaning that current is a fraction of the voltage divided by the resistance. So I mean that now comparing the values of the values of I and V, current will always be smaller than the voltage. Therefore the bigger one will be the voltage time graph, or the smaller one will be the current time graph. In this case then means that for the current I will have the I max, and then the voltage here will have the maximum voltage. Now we know physical sciences that if you want to find power equals to V multiplied by I. Therefore in this case, meaning that now, because these are the maximum, there's a V max and the I max, therefore they will give us the P max. That when we multiply these two, we'll have the positive power output at all times now. Another question may ask as well to say, why do we have positive power even if the current or the voltage are negative? It's because negative multiplied by negative equals positive. So even if the voltage and the current are negative, the power will remain positive. Now from here, if we use our knowledge of maths, if we want to find the average power will be half of the maximum power, P max, therefore which is the same as half of V max multiplied by I max. If we do further maths manipulation, therefore this will be the same as V max over root 2 multiplied by I max over root 2. We know that root 2 multiplied by root 2 is 2, which is comes back to 1 over 2. Therefore this is the P average. Therefore, but we know from our previous engagements that the average power, P average equals to V RMS multiplied by I RMS. What you see on the appliances is not the maximum, it's normally the VRMS if it's voltage, IRMS if it's current, and P average if it's the power. Now if you take it from the previous calculation that P average equals to V max over root 2 multiplied by I max over root 2. We can quickly say, therefore, if this is the first formula that we know, the first one, therefore it can now give birth to these two of, say, therefore V RMS will be the same as V max over root 2, that is number 2, formula number 2. Number 3 will be now I RMS, equate these two, equals to I max over root 2. There's another formula. We can say this is number 3. Now quickly, when we have got an element, normally at home we'll be finding this appliance that use the element for heating, which is the element is about with this high resistance appliances like your stove, your heater, your geyser. In that case, we know resistance in terms of Ohm's law is V over I. Therefore, it means that now the learner has got an option of saying, if this is RMS voltage, therefore the current must be RMS current, or this might be V max over I max. So you can't mix I max with RMS. So it's either you stick to the RMS in both cases or max in both cases, pick ones. That is the formula. Out of this one, then using Ohm's law, we can now say, therefore the power in the appliances will be the average power. If we use Ohm's law, then we'll have I RMS squared multiplied by R. This is another formula. Then remember, we've got also Ohm's law. That's another formula that we can take home and say number 4, and then this one becomes number 5. The last one will say power average equals to VRMS squared divided by R. Then this is the final one in terms of these formulas, which is number 6. So that's all the formulas that we have. If we take it back, the first one is power average equals to VRMS over IRMS. The second one, VRMS equals to Vmax over root 2. That one, IRMS equals to Imax over root 2. Then the Ohm's law equation, and then from here now, using that R in the power, then we can always make V in terms of I and R, or I in terms of U and R. So that is the case. Let's pause for now and continue in a few minutes.